This is the screencast for section 1.1, example 4. We're moving on to graphical models. A graphical model is the visual representation of the numeric or the algebraic models. They show it physically shows the relationship between the two variables or data points. We're going to look specifically at an example by Galileo here in example 4. Galileo Galilei spent a good deal of time rolling balls down inclined planes, carefully recording the distance they traveled as a function of elapsed time. What a party animal. His experiments are commonly repeated in physics classes today, so it is easy to reproduce a typical table of Galilean data. So here it is. The question is, what graphical model fits the data, and can you find an algebraical model that fits this? Well, we're going to do both. So first of all, if you remember, go to Stat, Edit, and please type in all the data into your calculator. Pause this, I will wait. After you've typed in all of your data, we're going to come up with a graphical model. So you go to Second, Stat Plot, which is the y equals key, and you turn your plot 1 on. So I have to go and hit enter onto on. I like this little dotted type up here. The boxes and the histograms, those aren't really going to help you. The dotted one's the best one for me. And then we are using list L1 and L2. I put my elapsed time into L1 and my distance traveled into L2. So now I'm going to hit graph. Now, I don't see very much of that data, but your calculator has a cool trick. If you hit zoom and then number 9, I mean you can arrow down to number 9, but you can also trust me and just hit the number 9 key. It says zoom, oh there it goes. It says zoom stat. Number 9 says zoom stat. We have statistics, so we're going to zoom to those statistics. The parabola goes to the origin, so I know that it's of the form y equals k times x squared. The problem is I just don't know what that k is. So I'm going to take an x and a y that's easy to use. Now 0, 0 is not going to help me because that's going to wipe out both sides. But I'm going to take a k and an x and a y from my data set, and I'm going to plug in. I'm going to choose this one right here. I'm going to plug in 3 for y. I'm going to find k, and I'm going to plug in 2 for x, and then I can, let's see, 3 equals k times 4. Divide both sides by 4. So 3/4 is k. Y equals 3/4 x, then x squared, excuse me, should be my parabolic model, my algebraic model that works with my graphical model. To test that, go to y equals, put in parentheses 3/4 or 0.75 if you're so inclined, x squared, hit graph. And there it is, a perfectly lined algebraic model to my graphical model. The now try problem that goes with example 4 is number 23. We're going to use some data on physics equipment to make our analysis here. Actually, we're going to make an algebraic analysis. A physics student obtains the following data involving a ball rolling down an inclined plane, where t is the elapsed time in seconds and y is the distance traveled in inches. Now, from our context clues, yes, you English people, I know that, the previous problem talked about a ball rolling down an inclined plane and then we had a parabolic pattern. Or maybe you're the type of person who can see that these numbers are related by a variable being squared. But maybe you're not. Maybe you forgot about the last problem. Maybe you can't picture how these numbers are relating visually. That's where your calculator comes into play. So if you put all the data into your calculator and turn your stat plot on, I'm going to make this plot number 1. Oops. And then hit zoom 9. I can see that I do have a parabolic pattern of data again. So I'm looking for another relationship that fits y equals k times x squared. I'm going to look for the easiest example I can to plug in. I think 5 and 30 is kind of easy, but 30 is a huge number squared. Actually, 30 is y, so I would be dividing by the 5 squared. I'm going to go with 30 and 5. Let's see. So 30 is going to go in for y. 5 is going to get squared. That's much better. So now I have 25k equals 30. Divide both sides by 25. K equals, reduce that fraction, that would be 6/5. So I think my parabolic model is y equals 6/5 x squared. Now, the question only tells us to find an algebraic model that fits the data. But man, I am so close to checking my work on my calculator and making sure I am right that I'm going to go that step. I'm going to do this. 6 divided by 5 x squared. Graph. Look at that, another 10 seconds of my time, and I absolutely know that I am right.